So in this video we will discuss about hydrometer. Hydrometer is a tool which is used for sedimentation analysis. So we need to know about sedimentation analysis, why it is carried out. Sedimentation analysis is carried out for particles having size smaller than 0.075 mm. So we should know the range, that 0.2 micron to 0.2 mm. So this should be the range. Below this particular range, 0.2 micron, Brownian motion is set up. And above this 0.2 mm, gravitational acceleration is set up. So our ideal range should be within this. Below this size, in order to analyze some special techniques like electron microscope or X-ray diffraction. These techniques are used to analyze the particle size distribution below 0.2 micron. Now we should know how the sedimentation analysis is carried out using hydrometer method. Basically, hydrometer is a device which is used for measurement of density of the suspension at a depth He at time t. You all might be versed with the formula rho SS is equal to 1 plus RH by 1000, where RH is the reading which hydrometer takes. Now we will derive this particular equation. So let us know how an hydrometer looks like. Hydrometer is like this, and here is some bulb, and we should note the readings. Just like reading is like this. If here is 1, then here will be 0.995, here will be 0.990, and here will be 1.005. So they increase downwards and decrease upwards. And negative sign denotes it's decreasing. I'll remove it and say decrease, increase. And this is hydrometer bulb. Okay, and here there is a heavy metal, and this is immersed in, say, liquid like this. And the formula is for percentage finer is RH upon 1000 into G upon G minus 1 divided by M by V into 100, where G is specific gravity of solids. So basically we'll try to derive this only. So let us assume, say, this is 1 ml fluid, and in this there is a solid whose mass is md, and this is surrounded by water. Okay, the whole volume, this volume I'm talking about, is 1 ml. Okay, sorry. So what is the volume occupied by soil solids? Solid. will be anything which will be md upon g into rho w, and volume occupied by water will be, this whole was 1 ml, so 1 minus md upon g into rho w. Okay, so what will be the mass of water? This will be 1, I'll write ml so that you don't get confused, minus md upon g rho w into rho w. Okay, so what is the total mass? I'll write it here. Total mass, which will be equal to mass of water plus mass of solids. So mass of solids md plus 1 minus md upon g rho w into rho w. Since rho w is 1 gram per cc, so we can take it 1 as well. Okay, now total mass will be md plus 1 minus md by g. Okay, so now I'll take md is common, then it will look like this. Okay, this is total mass, and what will be density? mt upon vt, and vt we knew that it was 1 ml, so it will again be like this only. Now comparing it with that equation which we had written above, 1 plus RH by 1000, here we wrote we are writing it again here. Now we'll compare these two equations. On comparing, we come across this result, md g minus 1 upon z. It implies that md will be equal to rh upon 1000 into g upon g minus 1. Now we know that this is the solids which we observed at height he at time t. So percentage final would be md upon 1 ml divided by capital M by V into 100. It implies that this is RH by 1000 G upon G minus 1 upon M by V into 100. Now we have come across this equation. So now I'll talk about the corrections which are required in hydrometer. The first correction is meniscus correction. Usually we observe the upper meniscus due to turbidity in the solution, which is wrong. We should observe the lower meniscus. If we are observing upper meniscus, that means we are getting low readings, because we know that the readings are decreasing upwards and increasing downwards. So the correction required would be positive correction. Second correction, let me type it as actual reading which we should have taken, and this is observed, which is not true. This is due to turbidity in the soil suspension. Next correction is temperature correction. If temperature is more, that means that density will be more or less? It will be less, which means buoyant force will be more or less. It will be less, which means hydrometer will settle down. If it settles down, that means we are getting more reading or lesser readings. We are getting lesser readings. So correction is positive. And if temperature is less, density of soil suspension will be more, buoyant force will be more, we will get more, means increased reading. So correction required will be negative. Now comes the third correction, which is dispersing agent correction. Now if we are adding some dispersing agent which will increase the density of soil suspension, which means buoyant force will be more, which means increased readings. So correction required will be negative. So now I'll be talking about the composite correction, which will include all these above corrections. It will be equal to Cm plus minus Ct minus Cd. This is dispersing agent correction, this is temperature correction, and this is meniscus correction. We know that meniscus correction is always positive. It depends on temperature, maybe negative or maybe positive, and this is always negative. So this was the discussion on hydrometer. Hope you understood it.